Hey everyone, we're going to look at the inverse of the cosine function in this case. Now again, if you remember, the graph of cosine is very similar to the graph of sine, and it goes somewhat like that, right? With this value being 1, this value here being -1, this being pi over 2, pi, 3 pi over 2, and so on. Okay, so again, this is not a one-to-one function because it fails the horizontal line test, right? So how do I find the inverse of this function? Well, I'm going to restrict the domain again. And just like sine, right, if you look from 0 to pi, right, if you look in this window over here, right, this window over here, we see that it's a one-to-one function and it assumes all possible values between 0 and 1, or between -1 and 1. Okay, so we're going to restrict our domain from 0, right, to pi. Okay, and then let's see what we get. So I'm going to go ahead and draw that part out. Okay, so this is 1, this is -1, and then I have pi over 2. Let's say this is pi over 2. And then I have pi. Okay, so my cosine function goes somewhere around there. Okay, so now what I need to do is I need to go ahead and reflect this over the line y equal to x. Now, just so you know, this is going to be messy, so we'll do this in Desmos. But we're going to try and reflect this over the line y equal to x. And so let's see what we get. So if I reflect this over y equal to x, well, first of all, my domain and range are going to switch, right? So this is going to be -1 over, so this -1 will fall, say, somewhere here. Okay, pi over 2 will be somewhere up here. All right, and then -1 would be out here. That's -1, this is 1, this is pi over 2, and then pi would be somewhere out here. Okay, so now my function is going to go this way. If I reflect it, it's going to go this way. Okay, so this pink curve here is going to represent our cosine of x, or cosine inverse. So this would be the graph of the inverse function for cosine of x. Okay, so before we get to Desmos, let's go ahead and define this function properly. And so here's how we define the function. Okay, so first of all, the inverse function of cosine is written as arc cosine of x or cosine inverse of x, right? And again, just like with sine, do not confuse this function. This is not equal to secant x or 1 over cosine x, right? Secant and cosine inverse are completely different functions, okay? So don't confuse them. So this is false, all right? Now, so y equals cosine inverse of x, okay, whenever cosine of y equals x, all right? And here, -1 is less or equal to x, less or equal to 1, right? So x basically are all the values between 1 and -1, and that is my domain and range, domain. And then y is 0 less or equal to y less or equal to pi, right? Since I restricted my domain now, it's only going to go from 0, right? My function starts, the lowest value is 0, and the highest value up is here is pi. So let's take a look at Desmos. Okay, so here's the graph of my cosine function, right? So this is your cosine wave. Here's, if I zoom it out, let's zoom in a bit. And what I'm going to do here now is I'm just going to restrict this function from 0 to pi, right? So this is your point 0, 1, and then this is your point, if you look at it, 3.14, that's pi, and -1, okay? And then I'm going to go ahead and graph the inverse function or reflect this over the line y equal to x. If I do that, I get this function, okay? And so this here is the graph of y equals our cosine, and as you can see here, right, its domain is from 1 to -1, right? So if you look at this point here, this is -1, and its range, the minimum value it takes, the y value, is 0, and look at the minimum and the maximum value here is going to be pi. So its domain is from -1 and 1, and its range is from 0 to pi. So let's take an example here. We want to find the exact value of y. First of all, y is cosine inverse of root 2 over 2. And then the second one, y equals cosine inverse of -1/2. Right? So just like we said in the definition, what does it mean for y equals arc cosine or cosine inverse of root 2 over 2? And we know that it means I want to find cosine of y equals root 2 over 2. Okay? So basically I want to find an angle y such that cosine of that angle is root 2 over 2. Now, if you remember, right, I'm just going to go ahead and draw my quadrants. If you remember, cosine was positive in the first quadrant and in the fourth quadrant. Okay, but this y has to be between 0 and pi, which basically means y has to be in the first and the second quadrant, right? So this one is out. Okay, now if you go in the second quadrant, cosine becomes negative, which is not the case, so I'm restricted to the first quadrant. So now think about an angle such that cosine of y is root 2 over 2. And that angle is going to be cosine of pi over 4 is root 2 over 2. Okay? Which means that y equals cosine inverse root 2 over 2, which is pi over 4. Okay? So if cosine of pi over 4 is root 2 over 2, that means cosine inverse of root 2 over 2 is going to be pi over 4. Okay? Let's look at the second one. So again, what does that mean for us? That means that I want to find the angle y such that cosine of y is equal to -1/2. Okay? Let's look back up here. Again, my domain restricts my cosine into the first and the second quadrant, right? Now, in the first quadrant, cosine is positive, whereas here cosine is negative, which means that is out. That means this is where my angle has to be, okay? And what value of cosine gives you 1/2? So think about your reference angles, remember? What reference angle will give you cosine of that angle as 1/2, and that is pi over 3, okay? So here, it's going to be pi minus pi over 3, right? So we know that cosine of pi minus pi over 3 or cosine of 2 pi over 3 equals -1/2. Okay, which means cosine inverse of -1/2 is going to be 2 pi over 3. Okay, and if you look, 2 pi over 3 is less than pi, so we know that 0 less than or equal to 2 pi over 3 less than or equal to pi. So we're good because this angle lies in our domain, okay? And so we can say that cosine inverse of 1/2 or -1/2 is going to be 2 pi over 3.